Again. Hi. All right, we're still doing construction. So this is going to be section 12-2. Let me go ahead and just get right to it. Share my screen. Open up that PowerPoint and get right to it. All right, so this is going to be short compared to some of the other sections here. This is on additional congruence theorems. So we talked about side, angle, side already. Now we're going to talk about angle, and angle, side, also called side, angle, and then properties of quadrilaterals. The angle, side, angle property, remember the order of those letters matter. That's two angles and the side between them. So if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, respectively, that's important. The respectively is important. That means like in that particular angle, then the triangles are congruent. Get that out of our way. The side angle, or you could read it backwards and say angle, side, whichever way, and partial to the side angle. Two angles in the non-included side of one triangle are congruent to the corresponding two angles and non-included side of another, the triangles are congruent. Now, we know that the sum of the angles in a triangle is 180. So if two angles are congruent, the third angle is automatically congruent. So really, this is just the same as angle, side angle. Right? That's all this is. Oh, look at that. So how are they the same? Well, we know the sum of the angles is 180 degrees. So two angles are congruent. We're guaranteed the third is also congruent. Therefore, angle, side angle can be written as angle, side, angle. Or we can just drop it to say side angle. Okay, angle is not a congruence property. If three angles in a triangle are congruent to three corresponding angles in another triangle, this is not enough information to determine congruence, but it does determine similarity. So I found you a picture to demonstrate that. This is a 45, 90 right triangle. Both of these have the exact same angles, but you can see they're not congruent. The side lengths are different. Side angle is not a congruence property. Okay, so if two sides in the non-included angle are congruent, respectively, you do not know congruence. In fact, you can show that by just fixing an angle in two sides. So if you fix that little angle down there at the bottom, the orange side and the green side, you can actually swing that green side in, make one triangle that's obtuse, or you can swing it out and make an acute triangle. So it's not enough to say, hey, there's only one triangle, because that's really what a congruence property is. It says, hey, with this information, we can make one and only one type of triangle. So by showing you that these two things being fixed can form more than one triangle, we're guaranteed that it's not always congruent. So a summary of the congruence properties. Now, I apologize for some of these slides. I know some of these pictures are kind of blurry and stuff. This is because I am just basically making them myself at this point. You know, I'm just trying to find pictures that I like, and they may not be the ones from the book. So even though at the bottom it says Pearson, copyright, all rights reserved, I should change that to Terra Stamps modified these. So please don't sue me. Anyway, so a summary of the congruence properties we have so far. We have side, angle, side, angle, and angle, side. Remember, that's the same thing as side, angle. It really depends on who you ask, okay? Those are the same thing. Why is that bottom right one, angle, side, and side, angle? Why does that one have two different names? Because the other ones are symmetrical, right? If you read those forward or backwards, it's the same thing. So we haven't encountered that yet. This is the first name that we encountered that can be read either direction. Okay, let's show that the triangles are congruent. Let's show that the red triangle is congruent to the black triangle. Well, we got those two angles. They're the same, the 70 and the 50. And then we have that shared side, that line segment BD. So these two are going to be congruent by angle, side, angle. Angle, side, angle. Two angles and the side between them. Okay, let's talk about these triangles being congruent, the red one and the black one. So you can pause the video at any point, and let's look at triangle ABC and triangle DEC. So what is it about those that makes those congruent? All right, angle C is the same in both because it's a shared angle. Angle ABC is congruent to angle DEC. Why is that? So they wrote ABC is congruent to DEC. These are both right angles. Okay, so we got a shared angle C. They both have right angles. And then the side between those, right? That angle C and the right angle, both of those have side length 3. So we have angle, angle, side, or side, angle, angle. 2 angles and the non-included side. So that's the congruence property. Now, this is an interesting fact. It is possible to have 5 parts of one triangle congruent to 5 parts of another one without the 6th part being congruent. These are called 5-con triangles. So look at the figures below. All the sides, oh wait, no, 2 of the sides are congruent. All the angles are congruent. So of all the 6 parts, 5 of them are the same, but they're not congruent. How is that the case? Well, everything comes down to corresponding. You know how I've been harping on the word respectively, meaning in that order. That's what's important here. That the angle that the 8 and the 12 make, or sorry, the 8 and the 18 make their, no, wait, the 12 and the 18, there it is. The 12 and the 18, that angle is not the same as the 12 and the 18 angle in the other triangle. That's what I was trying to say, sorry about that. So it's all about being in that particular order. All right, properties of quadrilaterals. We know what a trapezoid is, and we know that the consecutive angles between parallel sides are supplementary. An isosceles trapezoid, we know that definition. Each pair of base angles are congruent, and a pair of opposite sides are congruent. And if a trapezoid has congruent diagonals, that's what makes it isosceles. A parallelogram. Parallelogram has all the properties of a trapezoid, remember, because it technically is a trapezoid. Remember the hierarchy? Opposite sides are congruent, opposite angles are congruent, and the diagonals bisect each other. A quadrilateral in which the diagonals bisect each other is a parallelogram, and a parallelogram has diagonals that bisect. So it's one of those if and only if statements. It goes both ways. A rectangle is just a parallelogram with a right angle. It has all the properties of a parallelogram and thus all the properties of a trapezoid. All the angles are right angles. So a quadrilateral in which all the angles are right is a rectangle, and a rectangle has all right angles. The diagonals are congruent and bisect each other. Now we have a convex kite and a concave kite. Okay, so the definition there is a quadrilateral with 2 adjacent sides congruent and the other 2 sides also congruent. You can see the convex flexes out, the concave caves in. Lines containing the diagonals are perpendicular to each other. A line containing one diagonal is a bisector. Now here's the thing, you really don't have to memorize these, okay? If you were going to be doing like high school geometry, then you would need to know a lot of these properties. But these are well beyond the scope of elementary school. So if you guys are going to be doing something like, say, K through 5, then you don't have to worry about these kind of details. So then we got the rhombus, all of its properties. Don't worry about memorizing these. I just want to let you know that these are here, okay, that they exist. But I'm not going to test you on them. I'm not going to have you memorize them or anything. Okay, I'm more interested in the congruence properties and the constructions. And then we've got a square. All right. So now I'll just kind of breeze through those quadrilateral properties. That's because I really don't want to spend a whole lot of time and effort on those. So it's one of my favorite comics there when it comes to triangles. I always think about that one. Don't be so obtuse, you know I'm right. All right, so I know that there's a lot of stuff in this chapter. There's a lot of constructions, um, memorization, things like that. Fortunately, you don't have to memorize all that kind of stuff, right? You have access to your notes. You have access to um, these links that I gave you, so you can see these videos, things like that. So mainly, I want you to know kind of the how these properties work, how these congruence properties work, why they work, stuff like that. So all right, that does finish us up for section, what was this, 12.2? Yeah, the 12.2. Okay.